In these examples, we're going to show you how to express the domains of functions using interval notation. In the past, we've talked about two ways that the domain can be restricted, that is, that points can be knocked out of the domain, and one of them is bad points in the denominator, as we see in this example, but the other is the square root of radicals that have a negative number on the inside. So we are trying to avoid those undefined points. And so for this example, the points that are undefined occur when x is equal to -2. So I don't want x to be equal to -2 or +5, because those two values would give me 0 in the denominator, and 0 in the denominator again would be undefined. And if we wanted to write the domain using set builder notation, we could then just write this as the set of x such that x is not equal to -2 or +5. But when we want to write this in interval notation, we're going to take a look at the number line and see what we've knocked out. So we're assuming that unless we've got bad points or undefined points in other ways, that we are going to include all the real numbers, but then we will knock out those undefined points. So at -2, there is a bad point, so we're going to cross that out. And also at +5, there's an undefined point, and we're going to cross that out as well. So what we have is this number line that's been broken up. It's got two gaps in it, and each of those gaps will bring an end to this interval. So if you look at the number line, how many intervals are there? Well, I'm seeing 3. We got one here, one in the middle, and one on the end. So the first interval we will state with its lower end at -∞, and it goes up to the point -2 but does not include it. So I use a curved bracket. So that's the first interval. The second interval in the middle starts off at -2 but does not include it. It goes up to the point +5 but also does not include it. And then it ends at the point 5. And finally, the third interval starts at +5 and goes up to +∞. And when we want to state the domain, we want to say that we're going to use the union of these three intervals, because we want to include all of these points together with all of those points together with those. And so we will call this an OR. It's a union. And again, this is now the domain in interval notation. For example G, we are also trying to express the domain by removing the undefined points. So the undefined points are when the inside of this radical is negative. That means that what we want is that we want it to be non-negative. The inside, which is x + 3, should be non-negative, which means either positive or equal to 0. And so when we write this as an inequality, we then get that x is greater than or equal to -3. And we can show this on the number line. If we've got a -3 here, greater than shades to the right, and equal to means that this will be a square bracket. And when we want to write this in interval notation, the interval begins at -3 with the square bracket and continues up to +∞. And so now we have our domain in interval notation.